we're doing the second part of attack data stores, which is going to be largely a review of the stuff we already did in the SQL injection hands-on projects, and then we'll just talking about cross-site scripting for demos. All right, so I've got the lecture down here, such as it is. There's a few things in here that have not been covered in the Web Security Academy, but about half of this we've already done in the hands-on projects. So, one simple defense we talk about a lot is allow listing, or deny listing, where you try to block certain characters or certain words, and this is a famously unsafe way to provide security, as you can see. So you might, for example, most injections that we've used have a quotation mark in them. A single quote is what's essential for the injection, so if you block that, then you can't do those attacks, but there are attacks that don't use a quote. For example, if you have a numerical field, like just a number like 4, you can put in 4 or 1 equals 1 dash dash just right there without an apostrophe, and SQL will take it. So preventing apostrophes is not enough to block all SQL injection. Also, you can use string functions to dynamically create an apostrophe without literally inserting an apostrophe, and then if the filter just looks for literal apostrophe and it does not evaluate all functions first, then it will slip through. So here's ways to get in. So here's a, going to look for ename equals Marcus, and what you could do, instead of putting in the literal phrase Marcus, you could put in CHR in these pipe commands. This would be an oracle. In Oracle, this is how you build something, one letter at a time with numbers, and the point is, if one of these characters is forbidden, you will never see it. And so, and here's the MS SQL version of it, char. So that's one way to do it. You can just use a character code. Another issue is, for example, if they block the comment code. If you cannot inject a dash dash or a pound, then you can't put a comment at the end of an injection like this. So what you have to do is you can carefully create an injection that doesn't need a comment. So the purpose of this is like select star from users where name equals blank or 1 equals 1, and then you use a comment to eat up the last apostrophe, so you don't get a syntax error from an unmatched apostrophe. But if you put in this one, apostrophe or A equals A, missing an apostrophe at the end, then it creates a perfectly valid condition that accomplishes what you want, because this apostrophe the developer put here matches that one, ending the name, and this apostrophe that the developer put there matches this one. So this is a perfectly valid condition that is always true, and it does not require the comment. So that's one way to get around that. Then if you try to block the word select, then there's lots of ways to do it. Perhaps just using uppercase and lowercase letters will work because they did not change everything to uppercase before filtering. Perhaps adding a null byte in front of it. If you have a web application firewall, it's typically running code that was written in C, and code written in C interprets a null byte as a terminator of a string. So this might terminate the string before the select in the web application firewall, but not terminate it on the web server. And you can also put in this, so if there's one pass to remove the word select, it will remove the one in the middle, but what remains will be another select, and if it's not smart enough to pattern match recursively, it'll slide through. Here's ASCII encoding to send it there. Here's this is URL encoding, and this is double URL encoding, which was a problem if the URL decoding step is performed twice, which it is, fairly often as a fairly common mistake, then this %25 will turn into a percent, and then the %53 will be the capital S, and so on. So this unusual looking string full of symbols and numbers may resolve to a select. So you can try these things and they might get past the filter. Then you can use comments. If you can't send a space, you can put comments instead of spaces. Select username, password from users, and just put a comment in the middle of each one. That will be accepted and run, but it doesn't include any spaces. MySQL even lets you break up the keywords with comments, which might get past the keyword filters. And then there's second-order SQL injection. The SQL injection we were just talking about, you have a field like a username, and it goes right into a select statement that the developer wrote. But there's another kind called second order where you put in data which is stored in the database and used later. So you might handle the data. So you put in a name, for example, with an apostrophe in it. Like a lot of people do have apostrophes in their name, like O'Leary or O'Hare. So you just make a name with an apostrophe in it and store it in the database. Now, this is something you ought to be able to do. People really do have apostrophes in their names. The correct way to do that, into the SQL database is to add a second apostrophe. So when you insert it in, you have 2 apostrophes, and that will put 1 apostrophe in the database. That's the official way to do it. So that's fine. The problem is, if the other parts of the application are not written carefully enough, then when you try to do something else, like a password change, it will now read the password from the database with an apostrophe in it, and that will cause a syntax error. So you can put in a crafted name which will not cause SQL injection when you first enter it, but will cause SQL injection later when that name is used. That's called second-order SQL injection. And so here's an exploit. You make a user with this name, 1 apostrophe or 1 in select password for users, username equals admin dash dash. That's your name. Then you perform a password change, and it will try to use this name, and it will create an error here because 1 is not in that table. And it will say an error converting the character value to a column of data type int. So it tried to compare 1 to a password, and it couldn't because it was not a number, and it puts the value here. That's the actual password. The error message leaks out the information. This is one of the many things you can do. And of course, there's this famous XKCD cartoon where exploits of a mom, she named her son Robert apostrophe parentheses semicolon drop table students semicolon dash dash, and then when they try to use the names, they will lose all their student records. It'll delete their table. That's also second-order SQL injection. I saw a talk by Major Malfunction, Adam Laurie at FFCon, where he talked about how you could maybe do this to get on an airplane. You could make a name with a SQL injection, and maybe when they print it out of your boarding pass, you'd get on, be able to drop the database or something. He didn't try it, but another one I saw people do is they made a license plate, a fake license plate that had a string like this, hoping that a license plate scanner would get a SQL injection and adopt the database. And I saw people try that. I'm not sure any of those worked, but I'm not sure we would know if they did work. Certainly they could work. The only problem is, as you've probably seen in these projects, you can't guess the right injection. You have to try things and try other things and go back and forth many times. But still, I mean, if you were able to find the license plate scanning software and install it locally in practice, you probably could find injections like that. All right, so now the normal SQL injection takes you to a page where you can see some of the data that was fetched. And that's the easy kind of SQL injection where you can trick it into just fetching some data and displaying it right on the page with a union, for example. But if the results are not exposed, then you have blind SQL injection, which we've talked about, where you can actually run code on the server, but you cannot directly see the results of running that code. So there are things you can do. For example, you can just do destructive attacks, like shut off the server, drop a table, and you don't need anything to come back from the server to see if that works. That will take down the server. That's one way to go. And that's what that exploits of a mom was, just deleting a table. But that's not all that useful. Another thing you can do, for example, we've seen this before. Remember the steps we did in the project. So first you do you union select null and null null and null 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 to find out how many columns there are. Then you try to find an alphabetic column so you can put words in it. But suppose all you have is a numeric column. Well, you can convert the letters into numbers. So you could do this. You could take the substring of, say, the password 11. This will give you an A. Then you can do ASCII of that. So ASCII of substring, this would give you the number of the first character in a word. And you can put that in a numerical table. And then run it again to get the second character and so on. So there are ways to pipe alphabetic things into numerical fields if you convert them to numbers. All right, another way you can get data out is find an out-of-band channel. There may be some way, even though the data does not appear on the web page, you might be able to move that data somewhere where you can see it. Sometimes you can write it to another file that you can see, like an error log or something, and sometimes you can make a network connection out to a server you control. So in early versions of Microsoft SQL, you could connect to a server, apparently thinking you're going to go to another SQL server. You give it a server domain name and a port number and a user ID and password, and then you could select data and send it off to that server, which could be under your control, so you can just send the data to a server where you can read the results in the log, I think, at the other end. In Oracle, you can make an HTTP request to a server, and so here you go to an attacker-controlled server on a port number, and then you just put, instead of a file name in the URL, you put data taken from here, username for all users. So again, it will send a request to that server, which does contain information from the database, and you could see it in the logs. You just start a server listening on port 80, and it will go out. In Oracle, you can send a DNS request, get host name, and so he gets data from the database, select password, where username is sys.mdattacker.net. So it will go to password.mdattacker.net, and again, if you control the DNS server, there'll be a DNS request coming in. That domain will not exist, but you'll get the answer in the domain request. All right. And in MySQL, you can do select into out file. We've done this in some of the projects where you can select your data and put it in a local file as long as you can write on the local machine, and you can also use a UNC attack directing you to another machine as long as you have an SMB share. So if it's Microsoft SQL, you can set up a share allowing anonymous write access and then let the request write a file on your machine. These are all various ways to exfiltrate data. There's a lot of them. You can also use the operating system. You may be able to execute an operating system command, and then if you can upload a PHP file, for example, get a PHP shell or find some other form of command injection, then you can use the command line networking commands like TFTP, mail, and telnet that will make network connections and send data off. Or, as I said before, you can just copy data into a file in the web root so you can just browse to it. That's what we used in quite a few of the projects here. These are all possible ways to get data off a system. All right, let's take a look at a Kahoot. Take me a few seconds to log in. And this is going to be 9B1. All right. Avocado today. Oh, by the way, Tat, you're in the NCL, right? Are you Tat?
Yeah.
Oh, you're in NCL with just your initials, right? Is that right? Are you doing the National Cyber League? This thing here. Because there's someone in there with initials, and I thought it might be you.
Oh, no, not me.
You're not either. Okay, good. Thank you for telling me. Okay, good. All right. I'll just make a note. I'm just trying to find out who it is. All right. All right, good. Most of them use their real name. Somebody used just initials, and I'm not sure who they are. Godzilla shotgun. Oh, there you go. All right. Well, we gotta have enough people. All right, so which one of these will bypass a keyword filter? Okay, that's the one. This is URL encoded for the word select. All right. All right. Switch construction lets you put letters in a numerical column. Yeah, that's the one. This takes one letter of a password and turns it into a number. All right. All right. What defense can you overcome with a word like that? Yep, that's keyword blocking. It picks the select out of the middle, leaving another select behind. And what kind of SQL injection was this one, where you give someone a name like that, containing SQL characters? Okay, that's second order, because the injection happens not when you first put the data in, but later when it's used. All right. Repeat. JC. Oh, good. All right. So, go back to the slides. All right. And so, we talked about blind SQL injection. If your data query doesn't return any data you can see, and you can't find an out-of-band channel, you might be able to find some other behavior by the database that depends on your query. For example, here, if you put this in the text and anything for a password, admin '', then it will turn this into admin ' and terminate. So you'll now be selecting for username equals admin, so you'll log in as administrator. So that's a SQL injection. But if you put in admin and 1 equals 1, and admin and 1 equals 2, this one will log in because the condition is true, and this one will not log in. And this is what we used a lot of times in the projects. Yeah, I see your name, JZ. I'll put it in my notes. I think we know it, but that's all right. It's good to be sure. All right. And so now you can have a condition that's true or false, as we've done before. And so now you can try a condition like, does the first letter of this equal ASCII of 65, which is capital A? It does, so that will log in, and this one won't log in. So now you can ask any true or false question, and you can tell by whether you get logged in or not, whether the condition is true or not. You can also introduce conditional errors. Here you select 1/0 from the dual. Remember, this is a table, it's always there in Oracle, where this condition is here. And so if there is a username named DBS NMP, then it will be true, and it will select a 1/0 and create an error. But if the condition is false, it will not try to evaluate 1/0 and not create an error. So it amounts to the same thing. You can tell from the response whether you have a true or false condition. And here's another one where username equals AA. That's how you find out if a username exists. And you can use time delays, which we've also did in the project, and this is a lot of fun in Burp. So in MS SQL, there's a wait for delay command. You can put in an if statement, so it'll only delay if some condition is true. And then you can ask yes or no questions like we did, where you ask one letter, is the letter equal to 64 or 65, and try different values until you get in, which we did in Burp Intruder. You can test single bits, by the way. You don't have to be doing letters. You could use the power and command to pick a bit. So you could pump out bits from a binary number. If you have binary data you're trying to pump out, you could pick out one bit and see if that bit is greater than 0. And bit by bit, you could pump out the data with this sort of thing. You'd certainly want to script that, and I imagine you could probably figure out how to do it with Burp Intruder. If not, you could certainly do it with some Python scripting. It may, I don't know if this is in automatic tools like SQL Map, but it might be. And then in MySQL, you can have a sleep command. Older versions would have a benchmark command And I think in the projects we've also used like a ping command where you send 10 pings to the local host just to use up some time. There are various commands that just occupy some time you can use to create the delay. In Oracle, there's no function to cause a delay, but what you can do is try to connect to a server that doesn't exist, and then there will be a timeout, like 30 seconds or 60 seconds, while it tries to connect. So again, it will cause the delay if some condition is true. So here's a query where you would select A and make the request to this server where username from all users or username equals dbsnmp equals dbsnmp. So once again, only if this condition is true and that username exists will it try to make the connection, and that will cause the delay. All right, and so beyond SQL injection, if you want to move beyond just controlling the database, then you might want to get to the database server, the operating system, or you might want to get to other applications data and then pivot. You might want to, if you can get to the operating system, you can install network forwarding tools like SOCAT on the operating system, and then you can use this as a pivot to go pivot into other systems on the network. This is called horizontal motion through the network. And so then you can make network connections back out to your computer. You can extend the database functionality. You can turn on dangerous features that the administrator turned off if you get database administrator credentials. So that's kind of cute. For example, this is the famous one in SQL injection, XP command shell. In really old versions of Microsoft SQL Server, there was a function in SQL to execute command line commands. So it's just a shell right into the operating system right there. And Microsoft, you do something like this, XP command shell ipconfig. So you can just run command shell commands. So this was way too dangerous. And so Microsoft turned this off in like 2005. They also had ones that would read and write to the registry, which is also arbitrary code execution on Windows machines. And so ever since 2005, it's disabled by default. But if you can find the database administrator password somewhere, and we've done that in quite a few of the projects, then you can just execute some commands to turn it back on. It's still there, and you can turn it on. It's just not on by default. So that's good, clean fun. MySQL, we've used this. You can load a file and you can write a file on the system if you have write permissions. So you can read files, and if this is called insecure direct object access, if the permissions are not correctly set up on the server, then the MySQL process will be able to traverse to folders it shouldn't be going into and find files. And then you'd be able to read that data and write it into other files, perhaps, if you can find a folder you can write into that you can see. And then there's automatic tools to do this, of course. SQL map is the main one that professionals use, and so it does these things. It brute forces all parameters to find SQL injection points, so it just tries injecting apostrophes and other various characters into every possible parameter to see if it gets a response that suggests that it's vulnerable. Then it tries to perform a union attack on the vulnerable parameters by doing select null, 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 as we've seen, to find out how many columns there are, and then injecting letters to find a column with the character data type. Then it will inject custom queries. It can do things like concatenate multiple columns into a string. It can do Boolean conditions and do blind SQL injection with this and 1 equals 1, and 1 equals 2, and so on. And it can even do time delays automatically. All this is built into SQL map, so it's really very powerful, which is why all the pros use this tool mainly, unless they pay for expensive commercial pen testing tools. And you've used it in the projects. If you did the optional projects, you can pump out data from a vulnerable server. All right, let's try another Kahoot. This one. All right. Looks like hamburgers. Could be sushi though. All right. All right. So how do you execute operating system commands? XP command shell is the Microsoft way. All right, what's the tool to automate attacks? SQL map is the most powerful one. Nessus is a vulnerability scanner, and it might detect a SQL injection, but it won't really do the exploitation. It will just do the first step of SQL map, where it injects some funny characters and deduces from the response that you might have a SQL injection. All right. All right, what method will leak information even if SQL injection is totally blind? Time delays are the last resort. If you cannot find any different result, any different error message or anything, then you can always use a time delay to tell whether some condition is true or not. All right, which method reads a local file? Load file. Into out file writes a file. This reads a file. All right. All right, that's a tab. Good. All right, that's faces again. All right, good. All right. Looks like we can just carry on here. We're not too late yet. All right, so we'll talk about defenses, of course. How do you prevent this stuff? Well, the weak defense is input filtering, also called deny listing, where you try to block dangerous characters like apostrophes. This is very ineffective because some injections don't require apostrophes, and if you allow apostrophes into data you're storing by doubling them, you can have second-order SQL injection, so it's not very strong. Stored procedures make it possible to reuse code. You create a procedure that does some SQL statement, and then you can run it with a name. This is just sort of like a subroutine or a function. This does not improve your security necessarily. This just creates a function that can be reused by a name. So people sometimes say stored procedures protect you from SQL injection, but they do not. Stored procedures just make it easier to reuse code, but that might be vulnerable code. So you can define a procedure called register user. These hasted parameters Joe and secret, and then it gets executed here, but attacker can still inject with a password, exploiting it. So the thing that protects you is parameterized queries. This is the essentially perfect defense. It came out many years ago, and nobody's ever found a way to accomplish SQL injection once you do it this way. So what you do is you change the structure of the query so that the data that comes in is not literally placed in a string and then parsed. It's put in a data object. So you define the query structure. Select ename something from employee where ename equals apostrophe. This is the vulnerable code. where you make a line with apostrophe, then you add the user-supplied name, and then you add another apostrophe at the end. This is the dangerous way, because the name, which came from the user, is just added in the query. This is the stuff we've been exploiting all the time. The parameterized version, you put a question mark here instead of the code. You do not have an apostrophe and data from the user and then an apostrophe. You just have a question mark there, and then you have a different way to arrange the connection to the database. So now you put the parameter in as a parameter here and execute the query. So the question mark is replaced by data from the database, but it's not parsed as a line where a quote has to match another quote. It's just interpreted as a data object that's always here. So now you can have apostrophes in a database and it doesn't matter. Users can inject any funny characters and it doesn't matter, because all it does is try to find the data from the database and see if it matches that character that came from the user. This is the right way to do it. All queries should be parameterized all the time. Otherwise, you're just asking for trouble. All right, that's what you got to do. The wisest thing is just use this technique all the time and never use the other technique. Otherwise, you can be fooled. You think you're using parameters that are not user controllable, but then as your product goes through different versions and patches, eventually it may be that some user controlled data ends up in there, and then you've got a vulnerability. So if user data changes table or column names, this could be vulnerable. So again, you should only let it use known safe values. And you can't use parameter placeholders anywhere in the query, like sort by or otherwise. All right. In defense in depth, the application should run in low privileges, so that if you do have a SQL injection, they don't have the privileges to execute administrator commands on the box. Remove the unnecessary functions, apply vendor patches, and so on. And of course, subscribe to vulnerability notification services is a good idea. So you hear about recent patches. That's why following the news is very important to this business. You should know what new vulnerabilities and patches are out there. And then there's NoSQL. Facebook, I think, made this very popular starting about 10 or 15 years ago. Databases that do not work as relational databases like SQL does, a different kind of data. And the original idea of this was they used something called Cassandra, I think. And the idea was a normal database like MySQL is designed for financial data. So you have a record of, say, your balance for a credit card, and there might be more than one server, but all the servers have to be 100% synchronized. If you change your balance, it has to change the balance on every server immediately. So everyone is always 100% up to date. But for Facebook, you put a post on your wall, it's not really necessary that everybody in the world gets that immediately. It could sort of percolate through the network. It might take 5 minutes before that post appears in some foreign country, and that would be okay. So maybe you could have a more efficient database by relaxing this condition where the databases always have to be synchronized on every server, and just letting it send the messages back and forth asynchronously. And that stuff is called NoSQL. And it turns out to be used by a lot of companies, well, I'm not sure Facebook is still using it. So in SQL, you have to have defined fields. In NoSQL, you can arbitrarily define them. And so here's some query methods: a key value lookup, XPath, and JavaScript. These are ways to query NoSQL data stores. And so Mongo is the big one. A lot of people love Mongo. I've taken a couple of capture the flag tutorials and competitions where we learned to do a few exploits on Mongo. I don't really understand it, but a lot of people do use Mongo, and they're desperately searching for Mongo developers at least a few years ago. So here's what a Mongo logon code would look like. You create a Mongo thing, and then you have username and password matched here, and there you can see if this UID is set. So it's going to, here's a JavaScript function, and it'll tell if you're logged in or not. I don't understand where the UID was set, though. Object UID, somehow defined up here. Anyway, that's what Mongo looks like, and I really don't understand the details. I just see this part where it does fetch the data from the database and see if the username and password is correct. All right, so you can log, if you have this username, Marcus '// then this will inject into JavaScript, and the / will begin a comment. So you'll get in with username equals Marcus, and it doesn't matter what password you have. So it is possible to inject into Mongo, just like any other database. Here's another injection. You can use these double pipes, which I think interpreted as ORs. So username is A or 1 = 1. And the password has a similar one, A = A, and this password is A = A. So this condition is always true because 1 equals 1. I'm a little confused by this one too, really, because it looks to me like this ampersand, the second part looks like it's not going to be true. Oh, it's an or. Okay, this can be true or that can be true. This is going to see if the password equals something, which is probably going to be false, but this one is going to be true. The first one is true, and that's an or. So this injection will create a situation that's always true, and you'll log in. All right. All right, and then there's something called XPath, which is an XML-based database. So your XML data store, you see it's got address book, address, first name, surname, password, email, credit card, and so on, stored in this format. And the XPath query looks like this. To retrieve all email addresses, you have address, email, and text. This will retrieve these fields from the database in text. And if you want all the details of one user, you have square brackets with the condition, surname, text equals DAWS. This will get the details of that one user. And so you can inject into this. This is an injection that will, this is a normal query to retrieve your credit card number. So it's going to pick from the address table, the condition where surname is text and password equals secret, and then it's going to go get the credit card text from there. So that's the way it looks to fetch that data. You can do this injection, apostrophe or A equals A like we've done before, and now the password text will now be the condition will be and this or that. So again, the condition will always be true, and you'll get all the credit card numbers. So very much like SQL injection. So you can find these injection flaws by putting in some punctuation marks and getting syntax errors, same as you do with SQL. Here's ones that change the behavior without breaking the syntax by matching parentheses or quotes or avoiding quotes. And again, you might detect a change in the response that indicates the vulnerability. So to prevent it, you can filter with a whitelist or with a allow list or a deny list, where you block suspicious characters. All right, and then there's LDAP. This is used by Microsoft Active Directory and other systems to move directory information around a network. And LDAP queries look like this. You say username equals DAF. That will match a username. So to match any of these conditions, you'd put a series of them here, and the operator in front says OR. So this says OR these things together. So if any one of those is true, the condition will match. If you want to match all the conditions, you start with an ampersand in front. And for some reason, in LDAP, you always put the operator first and then the data. And that turns out to prevent SQL injection, just sort of by accident, because even if you can inject something over here in the data, you can't put the OR there. It was put there by the developer, and you can't put another one here. So you can't change the logic of this line. So it turns out in practice, most of these injections will not work, because remember, the way it works, we need to put an apostrophe or 1 equals 1, essentially. We need to be able to put in condition we control and an OR, and you can't put in the OR. So in practice, it's in principle possible to inject code, but in practice, most of these attacks won't work. So that's it for that. And we don't have any hands-on for those exotic ones, so it's just sort of theoretical information. All right, so which is the least susceptible to injection attacks? LDAP is least. By the way, I remember about 10 years ago there was a big stir at DEF CON. Several times at DEF CON, the Department of Homeland Security and the FBI have come in to like impound things and freak out because they had a vulnerability. And one of them was about 10 years ago when they had a bunch of Oracle SQL injection attacks at DEF CON, because there was Oracle is used by insurance companies and government agencies and large companies, and there was a belief that Oracle was not vulnerable. And at DEF CON and Black Hat one year, they came in with a bunch of talks saying, you can totally SQL inject Oracle, and the government freaked and said, oh, you can't tell people that. This happened several times when something really big appeared at Black Hat and DEF CON, and the government came in and made a fool of themselves trying to cover up the information. Anyway, Oracle is vulnerable in principle, just like the other databases. Yeah?
Did they, ever successfully, convince DEF CON speakers, not to speak?
It's a good question. Did they ever convince DEF CON speakers not to speak? I don't think so. I know the most famous case I know was the Cisco internal engineer who leaked all kinds of Cisco secrets after he'd been an internal pen tester at Cisco. And they came with the FBI and a court order, and they impounded all the disks from Black Hat, and they told him not to give the talk. And so he tried to give a different talk, and the audience booed, so he just gave the forbidden talk anyway. Then he got fired. He didn't have to go to jail, though. He got hired again. I imagine one case I think was Ron Rivest, the guy from RSA. His students hacked the MyFair MagStripe card, which is used by BART and many other subway terminals. And I think they actually did stop that talk. They prepared a talk explaining how to do it, and I think they actually delayed that talk for a few months. They actually didn't deliver it at DEF CON, but delivered it at a different conference later at the request of the FBI or Homeland Security that came in and said this information is too dangerous. So I guess it's been successful a couple times, but usually not. It's usually pointless by the time you give the talk. The information's out there one way or another anyway. There have been a few of those. Remember, I was involved in one of them called Insider, I think. There was an attack that attacked anybody using the TCP protocol. And it was considered to be fictional, but I found out how to do it from a criminal, and I demonstrated it at DEF CON. It's not super important, but it was an interesting denial of service attack that affected anything that uses TCP. There's a few of them. Anyway, there's a few attacks that became very notorious because people really freaked out and thought they were too dangerous and tried to suppress the information. All right, what's the best defense for SQL injection? Yeah, parameterized queries, not stored procedures. All right. All right, what system uses queries that look like that? XPath. I've never used XPath. I think not even in a capture the flag competition. I don't even know how to install it or anything much about it. Just a little bit of information is all I have. All right. What system uses these conditions with the ampersand at the start? That's LDAP. And I realize I'm wrong. I did find an XPath injection at a college library. Tried to notify them, they didn't care. But when I was doing security tests of a lot of college websites, I found one. Anyway, didn't lead anywhere too important, but I was sort of charmed to be able to do it. Anyway, that's LDAP queries. All right, and what defense might lead you to second-order SQL injection? Add doubling apostrophes to store them in the database can lead to second-order injection when you use that data. All right, there's Pete, who's won 3 times. And G, I don't know who that is. They'll have to give me more information if they want their points. And Cat, I know who that is. All right, good. So I'm going to stop this recording. Whoa, what's this?